Hi everyone, I'm Peter. I'm here today from Decision Lab. With me today is Wojtek from Migros Online. We're here today to talk about the digital twin that Decision Lab developed in collaboration with Migros Online in support of their picking operations in their warehouses. Before we begin, I'd like to say a special mention to some of the team who aren't here today. We have Sandy, Radek, Jacob, Pete, and Vadina. They're really the heart of this project, and I would just like to put the disclaimer out there that any particularly difficult questions we might be diverting to people who aren't here. So without further ado, I'll pass over to Wojtek, who's going to explain some of the context of the problem.
So, good afternoon, everyone. It's a great privilege for me to be here with you today. I work for Migros Online, which is a Swiss online supermarket founded 26 years ago. We are owned by Migros Group, which is the largest Swiss retailer and also largest Swiss employer. So Migros hires almost 1,100 people in Switzerland, which is quite a lot, 100,000 people in Switzerland. So as for such a small country like Switzerland, it's a big number. Our company operates on the e-grocery market, which is a market characterized by a low margin. So it's normal that it's very important for us to focus on process and cost optimization. This is why at the end of the last year, we have decided to create simulation and optimization working group, which got a mandate to create a digital twin of our distribution centers. After market analysis, we have decided to do such a twin with AnyLogic. And as our team is quite small, we needed a partner who has an already experience with AnyLogic, who has an experience with simulations. This is why we have partnered with Decision Lab, who built the proof of concept of this digital twin together with us. The effort paid off because the first proof of concept was built within 2 months, and already with this very, let's say, high abstraction level proof of concept, we could see benefits that digital twin could bring to our company. From the very beginning, we knew that we wanted to have a data-driven solution which would allow us to simulate our different distribution centers with a minimal change in the underlying AnyLogic code. We also wanted to have an API which would allow us to execute the code as a standalone or from external Java libraries, or an API that would allow us to plug in different optimizers that we are using. So the ultimate goal for the project was improving the warehouse efficiency through bringing the digital twin that would support strategic decisions of our warehouse managers and our IT department. So if we go a bit deeper into detail, at the beginning we wanted to focus on 2 things: evaluation of warehouse topology and evaluation of optimization and decision algorithms. When we talk about topology, it's important to highlight that right now our fulfillment centers do mainly manual picking, and there is quite a complex dependency between the picking areas. So we want to optimize, for example, size of these picking areas, size of picking buffers, or dependency between the areas, or the way picking paths are organized. We also want to be able to simulate slotting, so basically deciding how we place our products in the fulfillment center. We wanted also to have a tool which would allow us to simulate, to challenge our core algorithms. algorithms. For example, volumetric, so basically deciding which product are put together in a given shipping box, or composition of picking trolleys, so basically deciding which picking boxes are picked together, and last but not least, assignment of the workforce to picking areas and optimization of the workforce. What is also important when we look at the optimization in our distribution center, we want to be sure that if we, for example, focus too much on the optimization of shipping containers, we may actually increase the picking costs. So with the simulator, we want to be able to see all the factors together and take the best decision possible when bringing in the changes to a distribution center. So right now, we are in the second phase of the project. This phase started in May and will last till November this year. The team is distributed, so we have, in Switzerland, at Migros Online, we have people from logistic department, so warehouse manager and his associate. We have Java software engineers, so these are the people who normally used to work on the software that is running in our distribution centers. Right now they focus on designing the API with the AnyLogic and writing all the code behind it. And we have a decision lab, so who brings us their know-how from AnyLogic modeling and visualization.
Thank you. So to start, in terms of the model, we'll talk a bit about why we chose AnyLogic. First off, the warehouse in logic, as we'll explain a bit later, is very complex. And to capture this with as much realism as possible, we've modeled both agents and discrete events. So for example, we require the workforce to behave as agents, whereas the order processing is composed of discrete events. And of course, I'm sure we all know that AnyLogic is an excellent tool to combine these different paradigms. One specific piece of functionality that's crucial to the model is the transporter. So we use the transporter library and we customized it quite heavily. We require trolleys to transport the products around the warehouse, and the logic is very nuanced. We'll see more of that later. So it's particularly important that we could go to the low level of Java coding to specify the behavior in the transporter control block. It kind of links on to, again, the theme of Java, how we integrate it. So the fact that AnyLogic is Java-based has been supporting us with deployment. The Migros Online ecosystem does consist already of other Java applications. So it's been valuable for us to be able to execute the model programmatically and interact with other external Java optimizers, which we'll explain a bit more on later. Finally, as we've seen with a few different projects today, this solution is very data-driven. In fact, completely data-driven, meaning that even to the level of the conveyors that we use to transport products, they were created through XY coordinate input tables rather than hand drawing them on the AnyLogic canvas. So effectively, we were doing some of what was spoken about earlier of trying to programmatically translate a CAD file into an AnyLogic model. And this enables the center manager to simulate variations of both center layout and operational rules without changing the underlying code, which is obviously very important when we actually are deploying it and using it. So here's a 2D view of what the model currently looks like. Just to note, this phase of work is still underway, as we've said, so certain aspects are incomplete, but we can show you here it is as the latest version. You can see that the warehouse is split into different areas where the products are picked from racks and placed into containers. Each area is equipped with resource pools for both trolley and the workforce. And in the model, workers can arrive, leave, or move between areas. This captures the nuance of their shift operations. There's a directional flow to movement of products in the warehouse, which is reflected by the way you can see, well, it's quite small, but the way you can see that the conveyors have directions. And it means that areas have precedences. So for example, if a single customer order contains products from both area 5 and area 6, but area 5 is kind of upstream, then the picking operations in area 6 can only begin when all of the products are finished from area 5, and then the containers and the products are transported to area 6. Within each area, the paths connect product locations, and they define the routes that the trolleys can take. So the path network is subject to some fairly complex rules. Each segment can be configured to allow movement in either one or two directions. And on a bi-directional path, a trolley is not allowed to turn around instantly. So by that I mean in real life, a trolley is not allowed to turn around instantly, although the default behavior of AnyLogic is for it to turn around. So again, that's just another example of that kind of low-level customization where we kind of force it to pick a directed path to therefore kind of come back round and make sure it's on the direction that it wants to be on rather than just instantly spinning around. Also, each segment is subject to capacity constraints. For example, they might only allow two trolleys simultaneously on a path, which is to kind of reflect the fact that in real life, space is quite limited. This brought some of its own challenges again, in terms of there might be cases where a 3-capacity segment flows into a 2-capacity segment, and that can be quite challenging because you have to make sure that you're not creating this logic that goes in a circular kind of circular bottleneck where things get jammed because the things in one segment can't leave because the other segment's full, but then also nothing can get into the segment of where things want to leave from. So it can become quite circular, and took a lot of care to perfect that so that we get things working as intended. Products are transported between areas via conveyors. So complexity arises in the way that the conveyors actually merge together. It's not just as simple as saying one segment of a conveyor takes priority over another segment of a conveyor, which is, it's an easy rule to explain, but in fact, in real life, it's more of a ratio. So you might have 70% of products flowing from one of the conveyors and 30% of products flowing from another conveyor, and when they meet, you have to take them in that certain ratio. Buffers are storage places to hold product containers. Each buffer has a specific capacity representing the maximum number of containers it can accommodate. There are different ways to deposit into the buffer, either one by one coming off the conveyor, by bulk transfers, or by trolley runs, which is a concept that I'll explain a bit later. If a buffer is full, then operations may have to temporarily be suspended while we wait for available space. So that's something interesting to observe when the model's running. And then just to explain, as I was mentioning, how we actually arrive at a trolley run, there's some key components. One of the key components of a trolley run is the containers. So containers are any sort of packaging, such as bags and boxes, which hold products. And each container type is nuanced. For example, some are designed to hold cold products, and some must be specially sealed. They have internal dimensions, which relate to how many products they can hold, and they also have external dimensions, which relate to how many containers can fit into a trolley. So each trolley has a capacity for each container type. And again, there are multiple trolley types with variations in their speed and weight limits. There's a setup and release time required either side of picking operations. Finally, there's a workforce to operate the trolleys. So there's nuanced behavior in when and where they operate. And we have a system in the model with these operations that can impact the workforce. There's add operations, which is to basically introduce a new person to the model. There's remove, which takes somebody away from the model, and transfer, which means that they can basically change from area 5 to area 6. So yeah, the transfer specifically has been important because that happens in real life, because when different areas fluctuate in busyness, the workforce has to also fluctuate to match that. So the containers, the trolleys, and the workforce all come together as key components of a trolley run. So a trolley run is essentially where a sequence of products that need to be picked and assigned to containers before sealing and depositing. So in the model, when a worker becomes available, they'll be assigned to the next trolley run. And how we generate trolley runs is covered in this next slide. So as we mentioned, the AnyLogic simulation links to the kind of larger ecosystem of Migros, which includes a couple of Java optimizers that we use. So one of these is the container optimization. So the first implementation of this was a simple algorithm to kind of test how we integrate things, basically. The next stage that we're now working on is to ensure that they match current operations. But a future goal with these Java optimizers will be to basically refine and improve them and use the simulation as a test bed so that we can therefore come up with better algorithms that we can therefore deploy in real life. So in terms of the container optimization itself, it comprises of, well, basically an assignment of products from a single order to potentially multiple bags and or boxes. The algorithm takes into account product and container constraints. For the products, we consider quantity, weight, and dimensions. And for the containers, we consider the weight limit and the dimensions. The other algorithm that we also have is the trolley calculation. So that computes trolley runs constrained by the sequence of orders and the trolley types. It accounts for which products in the orders have already been picked, which is important considering certain areas follow the precedence that we mentioned before. For trolley types, we must consider capacity and availability. So yeah, overall, I think we've been really pleased that we've been able to separate things like this because it allows Migros Online to focus on what their specialism is, creating these Java optimizers, and it's been allowing Decision Lab to focus on what our specialism is in terms of making the AnyLogic simulation, and I think we've had a really strong working relationship in that way. So this is just quite a short video demo. As I mentioned, this isn't finished, but it's just an idea of the interface and to kind of show you some of the components that we're working on and currently polishing off. So obviously you can see the layout. You can see the green indicators are the trolleys, and the yellow indicators are the products. You can change the level, so the warehouse works on multiple levels, and you can also change the scale to zoom in and see what's currently going on in a certain area. There's a heat map to see the current concentration of activities. And there's also info panels to give information about buffers, resource pools, and the picking racks. We also have a page on the workforce to show the current status, and it also shows the add, remove, and transfer actions that I mentioned previously. And finally, we have some insight into the logic. This is just one section. That was just the conveyor logic. But we've kind of found that it's always useful to incorporate the layout and the flow diagram into the interface, because that really helps us with debugging and understanding of what's going on. And it's been great to use that to validate what's been going on from the Decision Lab point of view to the Migros point of view as well. Yeah, so I will pass you back over to Wojtek to talk about the benefits.
Thank you, Peter. So the project is new for us. I mean, we started at the end of last year. We had this proof of concept. Then a few months later, we started the second phase of the project. Nevertheless, we already see few tangible benefits. First of all, thanks to this tool, it's much easier for us to bring improvements to our fulfillment centers. Why? Because some of these changes are quite challenging and quite expensive when we need to change something physically. Let's imagine changing the layout of the warehouse. With this tool, we have a possibility to test and assess the changes before we do the changes into production. And in addition, it's much easier for us to get the management buy-in for any improvements. Because first, we do the simulation, we show how it worked in a simulation, so it's much easier to get an investment to do any changes. Already at that moment, we already have few interesting findings which allow us to do some optimization. And one of them was actually introduced into production today. And it allows us to reduce shipping costs by around 5%, even more what I have written here. And yeah, we are very happy from this change, from this optimization. Not everyone was happy because our transport provider, last mile and first mile transport providers, they were really upset when they saw that from now on they will have 4% less transport needs from us. Right now, we are really at the beginning of this journey, and we see lots of potential in it. For example, our company is building a new fully automated fulfillment center. In that case, all the automation, all the optimization comes from a provider of automation. From definition, such companies are not always so open to flexibility, to optimization, and so on. But having such a tool, we believe we'll be able easier influence them and engage with them, proving that our optimizer is showing our, let's say, digital twin is showing us some optimization benefits, so it will be easier to negotiate with them and also get the funding in case we would need to pay for some improvements in the machine. Long term, we also believe that we'll use the simulation in other parts of our business, like, for example, managing last mile delivery. And of course, before that, it's already what Peter said. In our current fulfillment centers, there is still lots of potential to optimize, and we'll work on it in the coming, let's say, years. That's all from my side. Thank you. Now it's time for questions.
Thank you.
That is a great presentation.
Thank you.
How did you get that 4%? How did you measure that 4% or 5% shipping savings? I believe you are talking about reducing the. I didn't understand what kind of savings are those. That is my first question. I have at least 4 more questions I have. If you could answer that, how do you determine that 5% savings?
In our case, in our company, we use a second-party provider to do the last mile delivery, and we basically pay for each shipping box. And the simulator, by doing some changes in the layout and some dependency between areas, showed us that if we do some merging of products between 2 areas, we'll be able to reduce number of shipping boxes by 4%.
Right. Perfect. Second question is, how long it took for you to implement this simulation tool?
So the first proof of concept was done at the end of last year. If I remember, it was 6 weeks project.
Yeah.
And now the second phase, which is and the first phase already showed us these ideas for optimization, and the second phase started in May and will last in till November. And in the second phase, there is in average 1.5 person in Decision Lab and 1.5 person at Migros Online who is working on it.
Okay. Is this any of this code that you're using in this comes with your warehouse management tool, the WMS?
Sorry, could you repeat?
You must have a WMS, right? Some vendor provided WMS.
We have our own
it's homegrown WMS.
Yes.
Okay, how much of simulation code that some of this code you must have been using algorithms, right? The optimization. How much of a code you're reusing in your model?
Right now, I would say it's not as much. The idea is that with this plugging API for plugging, where we'll be able to connect our, let's say, optimizers, our algorithms, we'll plug in the same microservice that we are using into production to run it with the optimizer. But this is the second phase. Right now, we basically had to write kind of high-level, how we could say?
Quite high-level rules at the moment, and
rules
we're working towards.
On our side, but the long-term idea is really connecting to the same API that is in production.
Okay, wonderful. And one last question, promise. Are you using slotting here, dynamic slotting? Are you able to simulate the dynamic slotting of locations during the, based on demand?
Your question was about slotting?
Yeah.
If we are able to
reslot your positions, locations based on demand.
Yeah, so the simulation is data-driven, as we said, completely data-driven. So if you can rearrange the input files and the input tables, then it can be dynamically regenerated to reposition products. What we're not doing at the moment is any kind of analysis on what the optimal movement should be. We're not doing that yet, but obviously we hope that could be a potential use case of this.
Right here.
Hi.
Great presentation, by the way. One of the thoughts that stood out at me was how you would influence automation providers, right? That's a very important question that needs to be answered. More often than not, you jump headlong into automation and then realize that you don't get the benefits out of it, right? In order to model any kind of automation, you need a fairly good sense of the operating of the system itself. How do you plan on doing that, or do you have a strategy for it? Thank you.
Yeah, this is a kind of our long-term dream, and we do know that we won't be able to probably to get to the same level of the, let's say, as the machine is operating, but we still think that some of the algorithms with a proper level of abstraction will be able to simulate them to some extent. For example, with our automation provider, we spent quite a lot of time challenging their volumetric algorithm. And it could be also easily done with a simulator, proving them that changing the algorithm could improve, let's say, decreased number of shipping containers that we need. But of course, there's some abstraction, and one-to-one may be quite challenging and expensive.
Hey, great presentation. Did I hear you said you automated the CAD drawings? So how do you evaluate different designs?
So it's a little complex. From the AnyLogic side, we're just essentially just using the Java constructors of the components. So for example, with the conveyor, we just need to make sure that all of the information like speed and start XY coordinate and end XY coordinate are taken in the input tables. And then from the side of how do we actually get that data, this is something that Migros have been focusing on. We have somebody who's dedicated to the conversion, basically, of the CAD files and the layout to the Excel input template. I believe it's done through some sort of Excel manipulation. It's kind of a separate process, is what I'm saying, separate to AnyLogic, to go from here's a CAD file and here are the XY coordinates, and then we can input like speed and things like that to kind of tack on and complement the layout data. So yeah, hopefully that answers your question, but to be honest, that probably is one of the ones where we'd like to pass it to somebody who's not here at the moment.
I think no more questions.
No more questions? Well, yeah. Thank you very much,
Thank you.
everybody.